Hi, this is Kuan from the Android X team at Google. I would like to talk about state retention today. So first, why do we need to worry about state retention? Because it's a bad experience if your app loses its state unexpectedly. Imagine that you are using an app, you go to another app, and then you come back, and then all your previous work has gone. So that is not a good experience. So we are here to help you to solve that. I want to focus on two situations today that your app might lose its state. The first would be config changes. I think we are all familiar with this. You can change the locale of your system. You can change the font size, or you can open your foldable, or even as simple as just rotate your screen. And then the system recreates your activity. The second case I want to talk about is this system-initiated process death. This is when the system decides that it needs to terminate your app process and to free up the resources for other tasks. When your app does not handle these two situations, it can get frustrating for your users. So I think that normally machines can do better at memorizing things than people. So if your app is more forgetful than your user, that is not a good sign. So how can we tackle that problem? There are many solutions. So on the framework side, we have this a couple of functions that can help you do that. We have this unsave instance state, unrestore instance state. Even in activities uncreate, you can get a parameter that can help you save or restore states. And when you are operating on these functions, you are actually handling bundle. A bundle is a type-safe way to save and restore your states. It's basically like a map, a string to any map. And a bundle is actually a parcelable. A parcelable is a way for you to turn your data classes into data in a parcel. And the parcel is kind of the basic element of data retention on Android. And the system uses it to do this inter-process communication as well. And to ease all of this, there's also a Kotlin compiler plugin called Parcelize that can help you generate a parcelable implementation. This is all the firmware stuff. And how about Compose? Compose has this function called remember savable that can help you save states as well. And when you are using this function, you are actually you may need to define a saver for your custom data class. On the architectural component side, we have view model, this AAC view model that can do this, handle this configuration change by itself. But if you wanted to also handle process death, you probably need to use something called SavedState handle. SavedState handle uses a SavedState provider internally and saves everything inside a SavedState. So you can see we have so many solutions. You can see, kind of feel that there's maybe context low in place here. So there's this kind of maps to our org chart in Google, maybe. So I work under architectural component, so I may be biased on which tag to choose to save your state. Yeah, I think ideally everything should be driven by SavedState here. And users or developers should kind of leave all the firmware stuff behind. And why is that? For two reasons. The first is that because an Android X library can iterate faster than the firmware libraries. So by using the SavedState API, whenever we publish a new library, you don't need to wait for a new Android release, and you can get the new features and new bug fixes. The second reason is that SavedState is a KMP library. So by using SavedState, you can enable your app to future KMP work. So ideally, we want you to forget about bundle, parcel, and Parcelable, all this stuff. But this leaves a question here. So if SavedState can actually SavedState is a type alias of bundle on Android, but how can we replace Parcelable? So here comes KotlinX serialization. This is a library provided by JetBrains that can help you serialize stuff. It has a built-in support for all kinds of formats. It has built-in support for JSON, protobuf, and there's a lot of other formats supported by the community. And by utilizing KotlinX serialization, we can serialize your data class into a SavedState. So let's say example without using SavedState. So this is when you are using a Parcelable, what it can look like. Let's imagine that you have a project data class that has an integer ID and a string name. First, you need to extend this, implement this Parcelable interface. And then you need to add some boilerplate code. And then here comes the meat. You need to override this write to parcel function. And here you use parcel to write your properties. And then there are some more boilerplate code. Here, the most important one is this create from parcel. You need to override this function so that you can read a project from the parcel. Also note that when you are reading and writing using these two overridden functions, you need to read and write them in order. If it's out of order, for example, if you read an int, you then read a string. You need to write the int first and then write a string later. If it's out of order, you get a runtime crash. Or worse, you may not get a runtime exception. And the code works somehow, but you don't know why. There's a Kotlin compiler plugin called Parcelable that can help you generate all this code. But since this is a Parcelable-based solution, it's still not KMP ready. You can make it work in a KMP project by using expect actual functions. But since at the end of the day, it's still using Parcelable, so it will be kind of weird to use that. So here's what we propose. That is using this KotlinX serialization to save your data into a SavedState. Let's see how it looks like. It looks like this. So this toolline can replace all those boilerplate you saw earlier in the previous slide. You just put Kotlin's serializable annotation in the front of your data class, and then you can we will generate that implementation for you to make it serializable. Note that this is a KotlinX serializable. It is not a Java serializable. And how to use it? We provide this top-level function called encode to SavedState. And then you just put your serializable class instance into it. And to restore the data, you use this decode from SavedState function, which is also a top-level function. Sometimes you may need to specify the type you want to restore. Yeah. In KotlinX serialization, everything is static typed. So this is the base layer functions. In addition to this, we also provide some delegates for you to use so that it's easier for you to save and restore states. The first one is the one for SavedState registry owner. So that means you can use this function saved in activity fragment, or if you use navigation, you can use it in your navigation backstack. So by using this delegate, we can save and restore this project value for you. Another extension we have is on this SavedState handle. That is when you are using view models, you can also use this saved extension function, this delegate, to save and restore properties for you. So these are the delegates. How about compose? In compose, we already have remember savable. So here we also add a new function called remember serializable. So instead of using remember savable and putting a saver for your custom data class, you can use a serializable object here with this new function called remember serializable. So how do we achieve this? Before we go into that, we probably need to first understand how KotlinX serialization serializes stuff. It basically contains two phases, two steps. On the left side, you can see this is your data class. And KotlinX serialization uses something called K-serializer to serialize this into the primitives. By primitives, these are not Java primitives. These are primitives of KotlinX serialization. So it contains basic data types like int, long, float, as well as Kotlin types like unit, like pair or triple. And after that, it uses an encoder to encode these primitives into a format. This format can be JSON, can be protobuf, or in this case, can be SavedState. And it is a similar process when we restore the data. So first, we use a decoder to decode a format into primitives. And then we use K-serializer to deserialize it back to your class. So how do we achieve this using KotlinX serialization with SavedState? We only need to implement this encoder and decoder part and leave the K-serializer part generated by the plugin. So by defining our own encoder and decoder, we can kind of create a new format for ourselves. In this case, this is SavedState. So let's see some of the presentations. When I say representations, these are kind of the encoded format that we do for you. That is how it looks like on system when you encode your data class. Let's see an example for primitives like an int. Here we encode the SavedState with the number 1, 2, 3. So how does it look like in SavedState? Remember, a SavedState is just a map of string to, you can think of a map to, of string to any. So it actually looks something like this. So here we have a key that is an empty string and the value is 1, 2, 3 here. The reason we chose an empty string here is that we need something for this root object. And we want it to not conflict with the property names of your data class. So empty string it is. So yeah, know that we may change this in the future, but for now, this is how it works. Let's see another example. How do we serialize objects? For example, for this project class, there's an int ID and a string name. We call encode to SavedState. With this project 1, 2, 3 awesome project, how does it look like? You can probably imagine this is something like a JSON. So we will actually encode it to something like this. Again, the braces mean this is a safe state. And inside this safe state, there are two entries. The first is ID. It has a value 1, 2, 3. And the second entry is name. It has a value awesome project. What if we want to encode nested objects like this? So in addition, this is the same data class as the previous slide. In addition to ID and name, now we also have a parent reference, a parent property that is also a project. How do we encode this thing? So here's the encode function. And we actually encoded kind of similar to how JSON encodes it. So you can see that this is the representation. So ID and name are the same. For parent, we just put that save state inside the parent save state. How about collections? First, for list like this. Say if we have a list of projects, how do we encode this? It actually looks like this. So here we have this decimal integer strings as key. And on the value side is all our project instances. The reason for this is that for SavedState, the keys are always strings. So we can now replace it with different types here. How about maps? Let's say that we have a map that's also a string that maps from strings to projects. How does it look like? As you may have guessed, it also serialized into a form like a list. So here we just put key value as items in this serialized form, in this serialized save state. The reason why we cannot put the keys directly into the keys of the save state is that because the maps key can be of other types other than string. So this is what we set on. Okay. So we've talked about how you should use SavedState. We have talked about how we implemented this serialization using SavedState. But what are things to watch out for? I think first is about this performance and efficiency stuff. So as you can see in the our representation format, the performance and efficiency may not match custom Parcelable implementation. This is mainly because we need to keep track of those keys. In a Parcelable, you usually don't write the keys into your output format. And why is that? The reason here is that we want the serialized format to be debuggable so that you can still look into your save state and see that what are the properties inside this saved state. The second things to watch out for is this size limit. At the end of the day, SavedState is still using bundle and parcel on Android. So you will still hit this 1 megabyte limit on Android. And this is not only for your app, this is also for the system. So please don't save too many data into SavedState. If you find yourself saving a bitmap, for example, into a SavedState, you're probably doing it wrong. The next is that the representation I showed you earlier is not stable. We may change things in the future, maybe for things to be easier to read, maybe for performance reasons, maybe for payload size reasons. And so please don't save the resulting save state into a persistence utility like a database or a shared preference, something like that. Next is you need to be aware of runtime. You still need to be aware of runtime crashes. KotlinX serialization is mostly static typed, so it can catch some crashes. Some errors at compile time, but it still cannot catch all the errors. For example, if you are using polymorphism, or if you are using something called contextual serializer, and that is when you can still get a runtime crash. Another reason is that in KotlinX serialization, this add serializable annotation is just an annotation. It is not a type. So you cannot define a type and say that this is serializable using KotlinX serialization. Yeah, so this is something to be aware of. The last one is that SavedState, although SavedState is KMP library, it is for now only KMP enabled. We don't say that it is KMP supported. It works on Android, but if you want it to work on other platforms like web, like iOS, you may need to do the wiring yourself for now. This is something I hope we can keep working on, so stay tuned. Yeah. I guess that's it. So please give SavedState serialization a try. Yeah, that's my talk today. Thank you.